These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the annotation. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the annotation. Thank you. Let's try this.
Okay.
You and I haven't talked about this. Do you? But you might have seen this in class. Do you know the method for this?
I believe so.
All right, give it a shot then.
Maybe.
I'll give it a shot, and if we get stuck, I'll give you some help.
Okay. Yeah. Okay, so f prime of x equals okay. Now the second derivative, the second derivative of 0. So this was the first one. Oh no. Yeah. So f1 plus, well, we have to do this again. We just did that, and it comes out to be this.
Let's see. Let's go back to that previous line.
Okay.
Describe to me, how did you get the 1 in the previous line?
E to the x, the derivative of e to the x.
Mm-hmm.
Yeah, okay. E to the x, derivative of e to the x is e to the x. Second derivative of e to the x is still e to the x. We went from, and this is correct, and then now, okay, so these here is just 1. Double check. So 1 plus 1 plus 1 times 0, 0. Okay.
Okay. Okay, so it looks like you understood the basic method here. So how do we read that last line? So
The second derivative of 0 equals 2, so that means...
not quite. What it means, the way we'd read it is the second derivative of f at 0.
Okay, yeah.
We're not taking the second derivative of 0. We're taking the second derivative of f at 0. So yeah, f double prime means the second derivative of f. What does the second derivative of f mean? It means the derivative of f.
Okay.
So f prime is the derivative of f, and f double prime is the derivative of f.
Okay.
All right, so if we really wanted to have fun, we could figure out f triple prime.
Okay.
We could take this pattern out as many times as we like, basically. So the point is, any function, you can find the derivative of any function. You can find the derivative of any function. F was a function, so we were able to find its derivative, which was f prime. But f prime was also a function, so we were able to find its derivative, which was f double prime. Okay, so you had the basic method down correctly. The only problem is, of course, if you have to take two derivatives in a row, that gives you twice as many chances for us to make careless mistakes. So again, this is why it was so important for us to really achieve mastery of taking those derivatives, because it's easy to make a mistake somewhere along the line when you're doing that. So conceptually, this was correct. We just made that careless mistake. All right, so I'll go back to my screen. And let's try this.
F prime pi over 4. So these derivatives, they just never go away in calculus. It's the root of the course, I guess.
That's right. So what is calculus about? Calculus is the study of derivatives.
Okay.
Or at least that's half of what calculus is about. And the other half we haven't gotten to yet. But one of the main things calculus is about is the study of derivatives. That's the reason why your instructor gave you that mastery test. That's definitely a good idea. It's pointless to continue unless you really have mastery of the mechanics of finding those derivatives. So we should be in pretty good shape since you did so well on that test. But you can see it's still easy to make careless mistakes. But I think we have a good base to build on there.
Okay. So, yeah, they're not so bad. They're kind of fun in a weird way. All right. This is just cosine of x. Oh, I always do this. I made sure in the test not to do this, but in practice I do this all the time. Okay. Now, the second derivative. So we got the derivative of secant x, which is the product of two functions. And we take the derivative of that and use the product rule. And we get cosine x tangent x plus secant squared x plus secant x, or times secant x. So Okay. Pi by 4.
Okay, so let's see. So you said there's a certain mistake that you have to guard against. What was that mistake that you were talking about?
Secant x.
Mm-hmm.
Um, for some reason, I want to see this as sine of x
Because they
a
both
lot.
start with an S.
Right.
Okay, yeah, so that's right. We have to be very careful not to treat the secant as if it was a sine.
Mm-hmm. And I think I took care of that. We went from secant x to secant x tangent x. That's the derivative of secant x. And then the second derivative of this, I believe we used the product rule here
Good.
because, so we took the derivative of secant x times tangent x plus tangent x times secant x. So derivatives, this is good, this is good, okay. Secant, so okay. Well, okay. All right. So we can't use the secant button, but we can use secant is really 1 over cosine of x. I'm not sure how to use secant on the calculator. I know we've gone over this.
What was your guess? How are you guessing that you should do it?
1 over cosine of x.
Okay, yeah, so you didn't have high confidence, but you were remembering that correctly. That is the correct method.
Okay. So inverse cosine. I need to review that. Pi 4 times tangent of pi 4 times plus so for secant squared x, I could just do the same thing, the inverse cosine, but square it. So
So how are you working out? So how did you figure out the secant of pi over 4?
the secant of pi over 4,
How did you do that on your calculator?
second cosine,
And why did you do that?
because it's the inverse of cosine. It's it's a
Okay, now actually that isn't what you had said a moment ago. What you had said, I thought, or maybe I misheard you, but I thought you said that the secant was 1 divided by the cosine. But maybe you didn't say that. But anyway, the secant of x is 1 divided by the cosine of x.
okay. I guess that's what I thought those buttons were, but I'm mistaken. Okay. 1 divided by cosine of pi divided by 4. Okay, secant squared. So do the same thing. Squared 1 divided by cosine of pi divided by 4, parentheses again, squared okay, my answer is okay.
Okay. All right. I'll go to my screen. All right, so for that problem that we just did, here's the choices. So which choice would you pick?
Well, it's most likely C, but let me double check. Second square root of 3 seconds 2. Yeah, C.
Because you confirm that that's really 4.24. Good. Okay, good. All right. So this was a problem I took from the problems your instructor has on the website. So you can see this was pretty tricky, but it looks like they want us to know how to do this. So let's review what were the problems here. So what's this?
That is secant x tangent x.
Which you know, but as you've already identified, there's a tendency to think of this as sine and get the wrong derivative. So we avoided that trap once on that problem, but then the secant popped up again. One thing I would say is, so it looks like we wouldn't have gotten full points on that. We made some mistakes, but you did do a good job using good notation. The way you wrote out your notation, carefully writing out the step by step and writing out the product rule, that was a good approach. It's still possible to make careless mistakes, but you used good notation and you did a good job of not skipping steps, but of writing down each step. So, excuse me. So the way you wrote that out was good. All right. Now another issue. What does this mean?
That's x times x.
Yeah. So it means x squared. Good.
Right.
What does this mean?
That's sine x times sine x.
Yeah. So is this an exponent?
Yep.
Yeah. So as you've noticed, this would be a more intuitive way to write the same thing. What does this mean?
That's 1 over x.
Good. So what does this mean?
That's 1 over sine of x.
Actually, unfortunately, that's a trap. Is this an exponent?
It's not.
Right. Do you remember we discussed that the mathematicians came up with bad notation here? This is what's called an abuse of notation, and you can see it deserves that insult because it's definitely confusing to us. So is this the same as 1 over sine of x? Are these two things equal?
Nope.
No. Even though if you trusted the mathematician's notation, you would think they're equal. So the mathematicians really played a trick on us. Just after we've congratulated ourselves on learning what the -1 exponent means, they turn around and they have this symbol mean something totally, completely different. Well, we just have to adapt to that. So is this an exponent?
Yep.
Yeah. Is this an exponent?
It is not.
No. Why is it not an exponent if it's in the same darn place? Well, just because the mathematicians unwisely decided to abuse their notation here. So do you remember what does this really mean? It really means inverse sine.
Right.
And you were actually saying that when you were doing it. You were saying you were doing the inverse sine, but you weren't realizing that meant that it wasn't what you wanted. So this is the inverse sine of x. Unfortunately, we've never had really much time to discuss what inverse sine means, but it doesn't mean 1 divided by the sine.
Right.
Okay.
It is 1 over square root of x minus, oh, sorry, the square root of 1 minus x squared, I believe.
Well, no, actually, I think what you're doing now is you're trying to find, you're remembering the derivative of the inverse sign. But that's not the same thing as the inverse sign. So
Okay.
what does this mean? You and I just have never talked about that. There's a lot of things we haven't talked about. So we've learned how to find the derivative of the inverse trig functions, but we never talked about what they mean. We haven't even talked about what the regular trig functions mean. We just haven't had time to get into that because we're focusing on how to get points for the test. So anyway, so we'll keep doing that. So let's see here. Here's the inverse sign of x. All right. So what does this -1 mean? Is it an exponent?
It is not.
It just means inverse sign. Okay. So now, what does secant of x mean? How can you figure out secant of x on your calculator?
We can plug in, well, we can enter 1 divided by cosine
Of x.
of
Good.
x. Yep.
That's right. Well, does that mean that we're really just doing cosine -1x?
No.
No, because the -1 for trig functions, -1 doesn't mean an exponent. It's tricky. We are doing this. We are doing this, but that's not what the button on your calculator looks like, right? The button on your calculator is not cosine x parenthesis -1. That really would be 1 divided by cosine. The button on your calculator, so it's this, not cosine -1x. Those are not the same thing, because this -1 is not an exponent, despite the way the notation makes it seem. It's an abusive notation, which is confusing. We have to fight against that. Okay. After all, you can see that what you're doing didn't make sense, because what you were saying is that the way to figure out the secant was to do inverse cosine, right? But that would mean that the secant is the same thing as the inverse cosine. So why would we need 2 different names for it? Right? If the secant is the same exact thing as the inverse cosine, why would we give them 2 different names? They can't be the same thing. Okay, if inverse cosine was really secant, why didn't they label it that way? Well, it's because they're not the same thing. All right, now something else that might come up then, this is not as likely actually. Actually, this is the one that comes up the most. All right, so that's the one to focus on here. Okay, so that's how to find the secant. Okay. So that would be a good problem to go back and try again. Okay, so we didn't get either of those double derivative problems correct, but I think you understand the method. You understood the method. We were just making careless mistakes and also some a problem here. So I think to save time, I'm not going to give you more problems like that, but it looks like there's a good chance that'll be on your exam. So you should go back and find the homework exercises that cover second derivatives and practice them. I think at this point you should be able to practice that on your own and make progress on it. So I'm not sure which section really has a bunch of those, but there should be a bunch of second derivative problems. Actually, it's probably scattered in different sections. There's a bunch of them in the trig section. There's a bunch in the various sections. So you should go back and do a bunch of those second derivative problems, because you can see it's not good enough to understand the basic method. It takes practice to learn all the ins and outs and to avoid careless mistakes on these. So that would be a good thing for you to practice on your own. These videos are offered on a pay-what-you-like basis. You can pay for the use of the videos at my website. There's a link to my website in the annotation. The address is www.freelance-teacher.com/videos.htm. Or you can just use the link in the annotation. Thank you.